Well, hi, good morning. Thank you so much for joining me in my shop. Today is, oh my gosh, January 1, 2025. Holy smokes. Can't believe it. But it is true. Okay, so what about this radio? Today, I think what I want to focus on is the power supply, especially the power supply filter capacitors. Commonly in a radio this old, those filter capacitors are an issue. Often they're not capacitating anymore and the radio hums. This radio doesn't hum. I didn't notice any hum at all in it. And at the same time it has this, what I believe to be an additional capacitor installed by somebody previous to me to boost the filtering capacitance. Fair enough. The weird thing about this radio, though, is it looks like all three of these capacitors, the added one and the two originals, which are right here, they are all tied to the same spot, which happens to be the positive post on this center capacitor, which I believe has leaked a fair bit of junk down in here. So wait a minute. You mean all three of these capacitors are basically in parallel? Not quite, because two of them are grounded to the chassis. I think we can include this down here. Well, maybe not. I have to look more closely at what's going on with this. This one is grounded to the chassis here via the wire coming out of it. This one is certainly not grounded to the chassis. It's carefully installed in the radio such that the outer metal can doesn't touch the chassis at all. So that's a little different. They're not all the same. If this guy is augmenting this one, then this lead would go to ground. But if this guy is augmenting this one, then the negative lead has to go the same place as the negative lead of this one. And I can see a wire coming out, and it's going. I can see it going straight down to this post. So that's what he's done. This one is just paralleling this one. Let's call this the floater. We'll say this one's grounded to the chassis. This one's floating. Why did you do that? Well, probably the set was humming, and I can't turn this. Well, we're going to replace this probably anyway, so I'm going to pull it out. 20. It's a 20 350 volt capacitor, 20 microfarad capacitor. Well, what I don't understand is there's a field coil in the speaker, yet the filter capacitors are tied together. Now normally the filter capacitors would be separated and then the field coil would run between them as an inductor in the filter system. So in radios without a field coil, they put a resistor in here, couple hundred ohms, something like that. But in this radio, there is no such thing. It's not a pi filter. It's just a one-shot filter, except one capacitor, or maybe two, because of this one, are not grounded. So how does a field coil operate then? I mean, how does this work? Or is this a mistake? Did somebody make a mistake and rewire things? So, but then I can't understand that. Doesn't make a lot of sense. Let's look at the schematic and see if we can sensify the situation. So I have to tell you, sensify is a word I just made up now. It's brand new in 2025 and you're free to use it. Sensify, to become sensible. Okay. Well, here's the field coil right here. T7. They didn't number it. Field coil resistance 2500 ohms. And it's connected. So look, here's the capacitor. Here's the other one. Now this is the grounded one because you can see the negative side comes down to the chassis, and this is the floater. Because of these, this voltage divider, or these two resistors here, arranging a negative bias voltage, or resulting in a negative bias voltage here. We measured this at 10, didn't we? Not 14. Isn't that right? Measured at 10. I don't remember. I just remember it was good enough. So the extra capacitor is paralleling this. And between the positives, there's nothing. It's just a wire here, just like you see in the radio. It's just, this is the way it's done in the radio. They just connect them together. Oh, that's so surprising to me. So how are they powering the field coil then? So one side is connected to the negative of this capacitor, and the other side is connected to the negative of this capacitor. So this capacitor negative is going to be elevated in voltage by some amount. Well, wait a minute. No, that's not right. What is going on here? Okay, so if we declare this to be 0 volts. Oh, I can't declare this to be 0 volts. It's the other way around. Wait a minute. How can... Okay, so I think the problem here is, I made a pot of coffee. I haven't drank any of it yet. So I think I'm going to stop and go drink some coffee because wow, there's something going weird here in my head. Yeah, coffee will fix this, I'm sure. And surprise, surprise, coffee seems to have done the trick. So I've come across quite a few radios over the years that have this kind of power supply, which can generate a negative voltage relative to the chassis, and then that negative voltage can be used as biasing. And you see that negative voltage right here, and they've written that right there, minus 14 volts. And up it comes. It ends up connecting to the grid of the output tube. So I have found this always confusing. And I think I realized the reason why. This minus 14 volts is what's confusing me. Because it really isn't minus 14 volts. It's really plus something. Plus something relative to the actual 0, which is sitting here. This is the real 0. This center tap line is really 0 volts. When you see it that way, then you can start to kind of understand what's going on here. So that's all I'm going to explain. Because the coffee's wearing out. The coffee's wearing out. If you consider this to be a plus some number of volts, I don't know what it would be, positive above this, then everything makes sense from here, from this point. And once again, I'm going to leave it at that. Yeah, trust me, I understand. Don't worry, take this pill. Don't worry, I understand. Here, take these pills. Okay. So what am I going to do? That's really the question, of course. What am I going to do? Well, I have to assume the two capacitors that are in here, the originals, if they are original. I'm pretty sure this is original. This might not be original. I'm going to replace them with small modern capacitors. This one I'm just going to cut out and get rid of because I don't need it in there once I put in some new ones. So we're going to cut it out right now. Cut it out. Maybe I'll leave that wire there. Yeah, why don't you do it for now? Always cut it later. Sprague, atomlytic. Atomlytic. Boy, they must have had a guy on staff whose whole job was to come up with new names for capacitors. Okay. So, let's see. So separating this one's easy because it's just wires, but this one's tough. It's got this terminal with a whole bunch of stuff hooked up to it. You have to take all that stuff off, and then what? Or could leave the capacitor in there. Could cut the negative wire off that capacitor. This is really the negative point here, if you like, or the 0 point here. This would be the winding coming out from the transformer. So I could cut away this wire, then that would leave the capacitor just sitting there. Like if I cut away the negative and leave the terminal here, you know what? That might be a good thing to do. just leave this all connected here. Cut away the negative line, put the new capacitor in to replace this one from here down to this wire. That's quite a distance. And do another capacitor to replace this one from here down to a grounding terminal. Obviously there's one way up here, but again, you know what I could do? I could cut the negative wire here and use the wire to hook up my capacitor here. Okay, that's the plan. Two capacitors in. One is 25 and the other was 16 I saw on the schematic. I will get them. There we go. We have the two new capacitors in. Just clean it up here a little bit. There we go. So what I did was I cut the negative wire from the floating capacitor and just brought it up and used it as the negative wire rather than going all the way down and connecting here. I don't need this anymore. And that disconnected the floating capacitor at that point. And then I used just this piece of wire here to connect the two positives from these, and then the negative, I stole the negative wire from this capacitor and brought it over and soldered it here. So ended up with a nice arrangement right in the middle of the radio. Great. Should we test this guy? Just see what's left of it. Test out this. So today's weather here has changed again. We've gone from rain back to snow, but it's not very cold out. -2 or something. But apparently there's some lake effect snow that may come through here. Big capacitor, it takes a while. So 30 microfarads is what it reads. 30 microfarads, and it's supposed to be 20. So I'm not sure what to say. I don't have a lot of experience testing electrolytics with this thing. Generally, what I found is if you read a capacitor like that and the reading is higher than the rating, then it's probably leaky and the instrument you're using is being thrown off by the leak through the capacitor. That's been my experience. Okay, we should test the radio now, make sure it's still working. So a very careful inspection, because you're right on the power supply here. And it all looks very good. Okay, let's give it a go. Now, I don't think I have the antenna switched on down here, so I'm going to stop for a bit, grab some more coffee, and turn the antenna on, and then we'll play this radio, make sure it's still operating. Okay, I think we're ready to go here. So I've hooked up a couple voltmeters. Each voltmeter is across one of those capacitors. This is across the one that is floating, and this is across the grounded one. And of course I've had to do it this way because this is a grounded meter and this is not. So I want to use this meter on the ungrounded capacitor. So just checking my leads here. So this is the negative for this guy. It's going to the negative spot there. Correct. And then I've got this connected. This green clip lead is just going to the other voltmeter. So these are the two, call it positive test prodes for the two voltmeters. They're going to the same place. And that's to this positive terminal here. And then the ground of the vacuum tube voltmeters, this clip on the chassis. It's right. I think that's right. I think we're ready. Okay, let me just put a few tools away here. Usually I like to keep my bench fairly clear of stuff during moments like this, in case a panic ensues. Talk about a panic. I think I'm a pretty calm, steady person. A couple days ago, my wife and I were working in the kitchen, and I took something down from a high shelf, and on top of it was a blender spinning blender blade part, you know, that you screw into the bottom of your blender cup with the blades, and it came off the top and fell from about 7 feet in the air straight down and hit my wife right in the back of her foot. The sharp point went boom, right into her foot, and the next thing you know, she's dripping blood off her foot, drip, 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 drip like that. I looked down at the situation and I just lost it. I didn't know what to do. I'm going left, going right. Should I get a chair so she can sit down? She should sit down. Should she sit down? What about the blood? Should we stop the blood? What about the bleeding? Meanwhile, she's saying stuff, and we have guests over because we have family over for Christmas, so they're showing up. What's going on? And when all was said and done, one of my sons came in and just calmly took control of everything. I realized that I lost it, and you know, I pride myself on not losing it. Boy, did I ever! It was useless. my bleeding wife, which oddly enough, I guess it must have pierced a vein or something like that and bled a lot, and then you put a little bit of pressure on it, it stopped bleeding, and it was gone. It was as if her foot was never pierced. There was no bleeding anymore, and just a small pool of blood on the floor. How weird is that? Never seen an injury bleed that much and then just stop. So she got a little bruise around it where it hit her. But anyway, the lesson is, you think lots of things about yourself, but when the rubber hits the road, you find out the truth. And the truth is, I'm useless. Not really. Not really. Okay, anyway. Now, let's see if this... So that's why I'm getting ready here. If there's a panic, I may freeze. I may fall to my knees. What kind of panic? Smoke coming vociferously out of this radio. So here we go. So we're switched on. The volume is up a little bit. We want to watch this voltmeter. This is set on the 150 volt scale. So this is liable to go right up to the top. And this one should read a little more than that one. So this one might go up 175. I don't really know for sure. It's one of the reasons why I'm doing this. The capacitors I put in are 250 volt capacitors, and they can sustain a short period at a higher voltage. But when they're operating, they should be, you know, down around 200 or less. Okay, I think we're ready. Just giving myself a chance to discover I'm not. So we're going through the dim bulbs. There we go. Whoosh, this went right over. Let's put it 280 to 300, so it's well above the rating of the capacitor here. This has gone down. This has now also gone down. This is really low, isn't it? No, maybe not. Okay, 150 volt scale, we're at 140. Our other guy, we're at 208. And I'm only feeding the radio with 103 volts, so we really have to raise it up and find out what this goes up to. Whew, that's close to the rating of the capacitor. You've got to assume there's a fair bit of headroom in the rating of these capacitors. So it says 250, you could probably run 300 and really not be taking any risk. So I'm telling myself. So we're going to let it settle down, which I think it has. And we're going to crank this up to 120 here. I think I'll leave the dim bulbs in the circuit. The radio's obviously, I think it's obviously working. Ooh, it's not obviously working. It's not working. Hello? Oh my gosh, this radio's not working. Uh-oh, that's not good. That is not good. What do we do now? Nothing bad appears to be happening, so we'll carry on here. Raise this up to 120, find out how high this gets. There we go. 115. 120. So this gets right up to the rating of the capacitor, and this one over here, it's going to be like 160, which is okay, certainly okay. What happened to the radio? Okay, it's just nothing there. It's very unnerving. Nothing appears to be smoking hot though. Oh my gosh. Where did you go? Huh. Oh. Wow. All I did was change a couple of capacitors. What else could have happened here? Well, the tapping didn't help at all. I'm going to drop this back down because 120 is a little high. Anywhere. Let's put it around 110 or so. There we are. Hey, Mr. Radio. How come you stopped working? I do have all the... I must have all the tubes in or we wouldn't hear anything. Okay, so we're going to inject some signals here. I'm just going to touch the grid caps on the top. She's got no sound. Nothing whatsoever. So changing the capacitors may have changed the B plus voltage throughout the radio. The radio may be operating in a different state now. We have one weak tube, and it's far-fetched where I'm going with that. I was going to suggest the higher voltage has silenced the radio. It doesn't quite silence it. We still hear some hissy stuff. If I inject a little bit of noise into the audio circuits, so let me grab the screwdriver here. Start by touching the, hard to see here, this is the output terminal. We hear nothing. Not sure what we would normally hear. Let me put my finger on it this time. Hard to see what's going on there. Not hearing a thing anyway. Okay, nothing there. So we would want to touch the grid of the output tube. The grid of the output tube is number 5. That's right, I remember that. At least I can claim I remember that. And what I don't remember is where's my flashlight. What did you do with it? What? I've lost my flashlight. Up in another one. Don't think any of these ones work. How about this clunker? I got flashlights everywhere and nothing working. Okay, we'll just try to do it sans flashlight. And no, I cannot see in there well enough to do it. Here it is. Okay, pin number 5. 1, 2, 3, 4, 5. That's the one I thought it was. So we're touching the grid. I'm going to put my finger on it in order to inject sound. Let me get my knee off the floor here. I hear a little bit, but a little tiny bit. That was right on the grid of the output tube. So this may have disturbed the grid bias, something big time. Why don't we check that? So grid bias, we can do it with the, we should do it with the grounded voltmeter. Okay. You think so? So we put this on negative, and we put it on the grid, and we should put this down to like, let's say 15 volts full scale, and we touch. We got a nice bias here of minus 12 volts, so that's not the problem. there just something I'm not thinking of here? Well, what could that be? There's only two knobs on this radio. Did I hook up the antenna, or did I hook up? Yeah, it's definitely the antenna. I put the switch on. The switch is on. Even if I didn't switch on the antenna, there's enough wire on the end of this to pick up signals. The radio is very silent, shows no response to tuning. No response to grid cap touching. There's another tube with a grid cap back here I can touch. This is the this will be the audio. Okay, so we're doing good from the. So there's no radio output. That's what it seems like. No radio output. Oh, demanding meter. Oh my gosh, she's gone silent. Why would you go silent? I'm fixing you up. You should get better and better all the way. You should not go this way. Okay, so before I do something stupid here, I'm going to disconnect this clip lead. This is the high voltage one. Get that off there. And this one's not at chassis potential. I get that off. Because I'm busy thinking about other things now. So this guy, we can take a break. Oh my gosh. That's about that's about the most I can say. Yeah, I feel like I'm at square one here again. Okay, coffee time for sure. So I think what I'd like to try is tracing the radio signal through the radio from the antenna forward until it disappears. I assume it's disappearing somewhere. So I think that might be a fun way to do this. So we'll see how this goes. So I need to use the signal tracer over here. Let's fire it up. So this guy is a radio and an audio amplifier. It does both things. There's a switch down here. Switch it from RF to AF. So we're going to switch it over to RF. Okay, so this also is a TRF receiver. It's not got any kind of conversion in it, but it will receive regular AM radio. And so I'm going to use this to test the antenna, make sure there is a signal there. But I'm sure there is. But we got to start. We have to start at the start. We want to do this, right? I got to move things a little closer here. Okay. So there's some volume controls on that tracer. One of them is like the speaker volume, and another one is like an input attenuator volume control. So we'll put the ground on the ground here. Okay, I'm going to use a clip lead. Pick up the, this will be the center conductor of the cable. Okay, we didn't hear much. So volume. Why so quiet? So there's two bands. There's an A band and a B band. The A band is for trying to receive the local oscillator in radios, and the B band is just the regular radio band. That's where I have it set now. Set to B. What's going on here? This should be picking up radio stations. It's quiet too. What's happened? Oh my God, has there been a nuclear war and everything's gone outside my house? Is that what's happened? I'll go up and see some kind of dystopian situation up there. This doesn't make sense. This doesn't make sense. Okay, so what I'm going to do is I'm going to release the antenna from the radio. Let's turn this down before I do that. So we are just feeding the signal tracer. Oh, careful, man! Don't hold two grounds at once. That's a little safety rule. Never bridge grounds. Okay. Take this off too. So this is just the signal tracer now hooked up to the antenna. A yellow clip in the shot. What do we get? Not much better. Oh, what was that? What was that big pop? Something funny's going on. Maybe there's been some kind of X-ray blast from the sun and all radio reception is gone in the world. Another dystopian explanation. Oh, this could be the problem. I don't have it hooked up to the outdoor antenna. I've got it hooked up to the radio. Oh, it doesn't do it. Volume's down. No, volume's not down. We're still getting nothing here. A lot of attenuation. Hey, what's going on with this? We're on B. B written right there. I've lost my mind. I totally lost it here. You know what? Maybe I made the coffee a little weak today. Nah, I don't get it. Okay, I'm going to stop for a bit because I don't know what to do here. Okay, turns out I didn't have the antenna switched on down here, so now it's switched on. Let's check it. Good show.
Is open to use. The ramp isn't closed, but again, it speaks through my careful as it stops.
It's a very broad bandwidth on the receiver. You can receive two stations at once here. But okay, we got an antenna signal. Was that why the radio was quiet? I didn't have the antenna turned on. Okay, let's go back to just put this back on the antenna. Put the antenna back on the radio, I guess is. And try it once again. Okay, power on. I'm sure if you do this kind of work, once in a while you discover that the reason something's not working is you haven't plugged it in. Look at it. Okay.
Is +3. Chance of flurries again tonight, -2 for a low.
Oh, weather.
We have flurries potentially for Thursday also with some sunny breaks. Now, alerts have been issued for areas north of the GTA. We'll start to see some squalls off of Georgian Bay tonight and tomorrow.
That's me.
So we are looking at some of that activity moving into the GTA. There's no alerts, but again, that chance of flurries, especially for northern portions of the GTA. Tonight's low, -2.
So GTA stands for Greater Toronto Area. So Toronto's a big city, but it's surrounded by more urban areas. And so they talk about that whole area as being the GTA. And that comes north about halfway from Lake Ontario to where I am. And so the GTA sort of thing stops, and then I'm north of the GTA, and that's kind of how it works here. Okay, fantastic, good. Radio's working. I was not. Thank you. I didn't go on some crazy troubleshooting. I did actually start the crazy troubleshooting thing, but Okay, what are we doing next with this radio? It's working now. We've solved the bad bias on the output tube. We've sort of re-energized this battery. This guy's still working. Why would I do anything with it?
Boxing Day deals store-wide with savings up to 85%.
So the accuracy here.
Home audio, appliances and headphones, car audio to car starters.
This would be 740. I can't leave it on there because it's going to be a copyright. So very close to 740. Say at 720, there's what it's showing. Go up to it. This is 820 from Hamilton. It looks like 810. 865 is 850. Pretty darn close. Getting stations up here. So that'll be a community radio station within the local area where I live, in the GTA. It's probably in the GTA. There's another one. I think this one's from Oshawa. Another one. I don't know where that's from. Oh, another one. Wow, she's working good. So this is 1580, I believe, the music one here. Not bad. Okay. I have to think now. Is it worth me doing any more to this radio, or should I leave it as it is? I mean, it's always worth doing more. In one sense. In other senses, there's a bit of a risk in fiddling around here. Is there some key things that I should do? I haven't done them all yet. That's my question. I could leave some of these old capacitors in here and just make sure the key ones are done. This is a transformer radio. So the whole hot chassis issue is not here at all. Got a big capacitor here, supposedly doing something from here to the chassis. Could parallel it and see what happens. I can hear a bit of a, to me it sounds like an open grid type hum. I could call it that. But it's very quiet. It's overwhelmed immediately when you turn the volume up. So it's not important. And that could be coming from almost anywhere. Good questions to ask. Another thing to do is to look at the clock on the wall. Yeah, I think I'm going to leave it here for today and ponder what to do on this tomorrow, or perhaps it's just back into the cabinet and she's done for now. What could I do that would really improve its operation? Probably not much. Okay, well, thanks a lot for watching today, and tomorrow we'll see if I can continue to operate this radio or not. I'll decide what to do with it. Yeah. See ya.